settle the moon before Mars, says astronaut Chris Hadfield. In the coming decades, NASA has some rather bold plans for space exploration. By the 2030s, they hope to mount their journey to Mars. A crewed mission that will see astronauts traveling beyond Earth for the first time since the Apollo era. At the same time, private companies, and organizations like SpaceX, and Mars One are hoping to start colonizing Mars within a decade or so. According to Chris Hadfield, these mission concepts are all fine and good. But as he explained in a recent interview, our efforts should be focused on renewed exploration of the Moon, and the creation of a lunar settlement before we do the same for Mars. In this respect, he is joined by organizations like the European Space Agency, ESA, Roscosmos, the Chinese National Space Agency, and others. When it comes to establishing a base on the Moon, the benefits are rather significant. For starters, a lunar outpost could serve as a permanent research base for teams of astronauts. In the same respect, it would present opportunities for scientific collaboration between space agencies and private companies, much in the same way the International Space Station does today. On top of that, a lunar outpost could serve as a refueling station, facilitating missions deeper into the solar system. According to estimates prepared by Next Gen Space LLC, such a base could cut the cost of any future Mars missions by about $10 billion a year. Last, but not least, it would leverage key technologies that have been developed in recent years, from reusable rockets to additive manufacturing. And as Chris Hadfield stated in an interview with New Scientist, there are also a number of practical reasons for back to the Moon before going to Mars. Ranging from distance to the development of space expertise. For those interested in science and space exploration, Chris Hadfield has become a household name in recent years. Before becoming an astronaut, he was a pilot with the Royal Canadian Air Force, and flew missions for NORAD. After joining the Canadian Space Agency in 1992, he participated in 2 space missions, STS-74, and STS-100 in 1995 and 2001, respectively, as a mission specialist. These missions involved rendezvousing with the Russian space station Mir, and the ISS. However, his greatest accomplishment occurred in 2012, when he became the first Canadian astronaut to command an ISS mission, Expedition 35. During the course of this 148-day mission, Hadfield attracted significant media exposure due to his extensive use of social media to promote space exploration. In fact, Forbes described Hadfield as perhaps the most social media-savvy astronaut ever to leave Earth. His promotional activities included a collaboration with Ed Robertson of the Bare Naked Ladies, and the Wexford Gleeks, singing Is Somebody Singing? ISS via Skype. The broadcast of this event was a major media sensation, as was his rendition of David Bowie's Space Oddity, which he sung shortly before departing the station in May 2013. Since retiring from the Canadian Space Agency, Hadfield has become a science communicator and advocate for space exploration. And when it comes to the future, he was quite direct in his appraisal that we need to look to the Moon first. According to Hadfield, one of the greatest reasons for establishing a base on the Moon has to do with its proximity, and the fact that humans have made this trip before. As he stated, with long-haul space exploration there is a whole smorgasbord of unknowns. We know some of the threats. The unreliability of the equipment, how to provide enough food for that length of time. But there are countless others. What are the impacts of cosmic rays on the human body? What sort of spacecraft do you need to build? What are the psychological effects of having nothing in the window for months and months? And going to a place that no one has ever been before, that can't be discounted. In that, he certainly has a point. At their closest, that is when it is at opposition with the Sun, which occurs approximately every 2 years. Mars, and Earth are still very far from each other. In fact, the latest closest approach occurred in 2003, when the two planets were roughly 56 million kilometers apart. This past July, the planets were again at opposition, where they were about 57.6 million kilometers apart. Using conventional methods, it would take a mission between 150 and 300 days to get from the Earth to Mars. Whereas a more fuel-efficient approach, like ion engines, would cost less but take much longer. A more rapid method like chemical rockets could cost far more. Even with nuclear thermal propulsion, or the variable specific impulse magnetoplasma rocket concept, the journey could still take 5 to 7 months. During this time, astronauts would not only be subjected to a great deal of cosmic radiation, they would have to contend with the effects of microgravity. As studies that have been conducted aboard the ISS that have shown, long-term exposure to a microgravity environment can lead to losses in bone density, muscular atrophy, diminished eyesight, and organ damage. Recent studies have also shown that exposure to radiation while on the surface of Mars would be quite significant. During its journey to Mars, the Curiosity rover recorded that it was subjected to average dose of 1.8 millisieverts per day from inside its spaceship, the Mars Science Laboratory. During its first 300 days on the surface, it was exposed to about 0.67 millisieverts, MSV, per day. This is about half and one-fifth of what people are exposed to during an average year on Earth. While this falls outside of NASA's official guidelines, it is still within the guidelines of other space agencies. But to make matter worse, a new study from the University of Nevada, Las Vegas, concluded that exposure to cosmic rays could cause cell damage that would spread to other cells in the body, effectively doubling the risk of cancer. The risks of going to the moon, in contrast, are easy to predict. Thanks to the Apollo missions, we know that it takes between 2 and 3 days to travel from the Earth to the moon. The Apollo 11 mission, for example, launched from the Cape Kennedy on July 16, 1969, and arrived in lunar orbit by July 19, 1969, spending a total of 51 hours and 49 minutes in space. Astronauts conducting this type of mission would therefore be subject to far less radiation. Granted, the surface of the moon is still exposed to significant amounts of radiation since the moon has no atmosphere to speak of, but NASA estimates that walls which are 2.5 meters in thickness, and made from lunar regolith will provide all the necessary shielding to keep astronauts or colonists safe. Another good reason to go to the moon first, according to Hadfield, is because expertise in off-world living is lacking. There are 6 people living on the International Space Station, and we have had people there continuously for nearly 17 years, he said. But the reality is we have not yet figured out how to live permanently off-planet. So I think if we follow the historically driven pattern, then the moon would be first. Not just to reaffirm that we can get there, but to show that we can also live there. But perhaps the best reason to settle the moon before moving on to Mars has to do with the fact that exploration has always been about taking the next step, and then the next. One cannot simply leap from one location to the next, and expect successful results. What are required is baby steps. And in time, sufficient traction can be obtained and the process will build up speed, enabling steps that are greater and more far-reaching. Or as Hadfield put it, for tens of thousands of years humans have followed a pattern on Earth. Imagination, to technology-enabled exploration, to settlement. It's how the first humans got to Australia 50,000 Oregon 60000 years ago, and how we went from Yuri Gagarin and Alan Shepard orbiting Earth to the first people putting footprints on the moon, to people living in orbit. Based on this progression, one can therefore see why Hadfield, and others believe that the next logical step is to return to the moon. And once we establish a foothold there, we can then use it to launch long-range missions to Mars, Venus, and beyond. incremental steps that eventually add up to human beings setting foot on every planet, moon, and larger body in the solar system. On the subject of lunar colonization, be sure to check out our series on building a moon base, by Universe Today's own Ian O'Neill.